Hello and welcome to question B1 on the 2023 paper. This is an intersecting solids question. So a 3D graphic of a desk lamp is shown on the right. So here's our little desk lamp. The lamp consists of a truncated pentagonal prism. You can see here in plan we've got our pentagon. And a truncated equilateral prism. Okay, so we've got the true shape of that prism as it cuts down. And it's been cut at the various angles. And both of these intersect each other as shown. Figure B1 shows the incomplete projections of a similar lamp. So what they want us to do first of all is to draw the given plan and elevation. Okay, so we always like to follow the question and see they said plan first, so that might guide us to draw the plan for a start. And that's what we will do, because drawing that pentagon will help to determine points then in our pentagonal prism. We can measure them then for the truncated equilateral triangular prism. So let's start with that. I've got my XY line drawn there on my paper. Put that there so we can see it. Oh yeah, also one other thing, we've got a scale 1:2. So basically all our measurements here, we're just going to divide them by 2. Okay, so it's a nice easy scale to deal with. So I'm going to start here with my side of length 88, which is going to be 44. I've done a decent distance there, so 80 should be enough. And yeah, about there is fine on the page. Okay, so length 44. Okay, and let's measure our 72-degree angle for a pentagon. So 72. Just on the bottom half, 72 degrees. Okay, and each side here is length 72, so sorry, length 44. So just to make sure I'm doing all of this accurately, I'm going to get the same length here for each side, 44. Okay, and there I've got my pentagon. Okay, and actually put some of those edges in heavy, which I will do. We might as well while we can. And that's a heavy line representing the top edge of our shape. So, okay. So now I'm going to draw the elevation of that pentagonal prism. So just slip that to the side. So project up my base, pentagonal base. Okay, and with a couple of measurements here now, we've got 160, which is going to be 80. There. The overall height, which is 220, which will be 111. Put that on heavy. And we've got base running up here, which is an angle, oh sorry, that's an angle of 40, so I'm showing that back. Okay, and some of this edge will be a heavy edge. I'll just draw it there for now. And join that Okay, so that is our pentagonal prism. Okay, we are going to now start on the projections of our equilateral, truncated equilateral prism. Okay, so we'll just deal with the equilateral prism first of all. So let's find this point here, just out 15, not 30, 15. Okay, we've got this angle 40 degrees, which is unusual, but we'll deal with it. Okay, and just to allow enough space for everything here, oh, that's going to be 15 up from there, so 15 up. The top of that, and we'll further. So we'll start our triangle there, our equilateral triangle. Okay, so our equilateral triangle is going to be of side 80, which using our scale is going to be side 40. Okay, it's an equilateral triangle, so all sides are the same. So set my compass to that, radius of 40. And let's have true that. Our true view, our auxiliary view of that. Okay, and we can project that back down at that same 40-degree angle. There. There. Okay, so now I'm just going to start filling in my truncated parts here. So I've got my 30 marked off. I'm going to 10, 20, which is going to be 10. And that's going back 30, so that's going to be back 15. Straight up there. Okay. So now I can draw that part or that side of it in. Okay, so that's the left-hand side in elevation. Okay, and now we just need to draw the right-hand side. So I have that height. Join there. There's going to be a heavy edge across there to a distance of 120 from the edge, so that's going to be 60. Okay. I think that's pretty much my elevation setup. Okay. Yeah, that's my elevation setup. Now I need to just complete the plan. So everything I have there, I need to start projecting down. Project down. Center of that triangular prism is in line with that center of the pentagon, or that apex of the pentagon. So let me just draw a line there across the middle representing that. And we know that width here is going to be the same as our same as our equilateral triangle. So that will be 40, 20 either side. Okay. Right, so I'm going to start filling in some of my heavy parts. Heavy there. That won't have it. I'll draw a portion of it, same with that. Draw a portion of it. Not really going actually all the way to that edge. That edge. Okay. We're not going to be able to find all of this. Find some of it down. That represents the same edge. That's a point. Okay, I'll talk about finding the rest of that in a moment. I'll just deal with the left hand side for now. So project all these down. Okay, so we'll start with that bottom edge. There'll be a hidden detail line. Okay, we've got top of the triangle is there, so that will go to here. We don't have those two parts yet. I'll put that in wrong. This will be in here somewhere, and will be traveling in here, traveling in here. We're going to have our hidden detail. Okay, right. So we just have the two sides here, the left and right hand side of these triangles to find. Okay, I'm going to start off with this side here. Okay, so if I extend on, this triangular surface, what will be resulting is a horizontal cut there through our triangle, or through our prism. Okay, and if you imagine when that slice is taken through it, okay, it would result in triangular kind of surface resting on the ground. So that's kind of what we would result in, okay, when that slice is taken. And that will contain those 2 points that we're looking for, okay, and that edge. So let's do that. First of all, I've that already actually extended, so I can project it down onto my center, and I can join that back like so and like so, and that will give us those two edges and 2 points, and a heavy line then, join them, and we just need to finish off a little triangle then, join back to there. Heavy. Okay, so that's one side of it. Okay, now the other side of it, we are going to be doing something similar. Okay, so if you imagine another cut, use a different color this time. So this is like another horizontal cut through my shape. okay, resulting in another kind of triangular shape, surface or a triangular shape. So if I find this point here and drop it down, I already have that point. I'm creating this triangular orange surface. If you want to think of that. Okay, so that's what I'm trying to find, and that will give me those 2 points. So I've got this extended out to there. That will be the end of my triangle. Drop that down. I can join back then to that other point. That will actually give me the triangle I was looking for. Okay, so there we have it. That is plan and elevation found, okay, the given plan and elevation. So a bit of knowledge there of horizontal sections in the setup and that, okay. Then complete the projections of the desk lamp showing all lines of interpenetration, include all hidden detail. Okay, so we'll start with our limits method. Okay, so this is a flat surface, so that point and that point we can just drop down and drop down, so we'll get points there and there. Yeah, so that'll be limits on the left. So any limits on the right, that point is a limit going along that flat surface, and you can see it there in the graphic. You should always try and use the graphic if you can. So I can drop that down and find another point. Okay, and then this is a flat surface containing that point right here. So we can actually work in reverse then up to find a point there. That is the most. There's going to be one more turning point in here, but I'll find those once we begin it. Okay, so drop some of these down. Point, point. These are my limits. Okay, and that will be a hidden detail line, hidden detail edge there. Okay, so that's my left hand side. Adjusting down for those. On the right hand side, so that was a point on the limit. We could bring down. Okay, so that would be a heavy line into there. Alright, so these we're going to project up. So find that limit point. And there. All that's left then is we need to find a kind of turning point here, okay? So we can see it, there's a turning point along that edge. Alright, so what we can do is we can take a section again. So this plane here, I'm trying to find a color that would represent it, so this yellow. If I extend that plane through the shape, okay, it'll contain that point. Okay, it's hard to see in the printout that I have here. So we're going to extend that plane. Okay, and that's creating this triangular section. Drop that down. So there are 2 points on a triangular section, okay, which I can join back to there. Okay, so it's containing a better sketch than what I have. So basically, I'm drawing something like that through my shape, and that contains that point there. Okay, so drop that down, join that to here. So that is going to find that turning point. That turning point there, which we in turn then can project up into our elevation. So that will be there, and that will be a heavy line to there. And then to finish it off, we're going to have heavy edge, the hidden detail. Okay, so that is the solution there to the 2023 intersecting solids question. Okay, a lot of work in the setup there, and other than that, just that tricky little bit here, to be honest. The rest of it was limits. Okay.